Assalamualaikum sir. I am Riyad Sinrapi. My ID is 19101511. I'm going to be introducing our progress part of our automated irrigation system project. Here we have a water level and a soil moisture sensor attached to Arduino Uno. Along with that, we have a GSM module to set SMS and a pump to pump in water in our tank. And here we also have a CAN pin to interface our output. Now, if we look into our sensors, they both have one analog output connected to our Arduino and other connections to properly power them. Aside from that, each has one test pin connected to our variable register so that we can simulate our sensors by manually manipulating the values. In our Arduino's analog signal connection, we also have two connection for clock and data to our I2C module to display our data. However, you can see that in our Arduino, they aren't actually in TXT and RxD. That is because our TXT and RxD are already occupied. That is why we are using virtual RxD and TXT by using a software serial module in our Arduino code. Finally, we have the TXT and RxD pin connected to our COM pin to interface our output. Also, you can notice that there are two virtual terminals attached here and here. This is just to show us a reading of both of these modules.
Hello, assalamu alaikum. I am Abra Salim. I'll be explaining this Arduino code. So let's get started. At first, we imported all these necessary libraries for our Arduino code, and we defined this. We define our necessary sensors to necessary pins. After that, we initialize this SMS send variable, boolean variable to false. This boolean flag will be needed in checking the water level below 50% for sending SMS. After that, we initialize this loop iteration variable for keeping track of the iteration. Then we initialize the LCD and GSM serial. Now let's look at the setup. At first we set up the LCD, then all the other soil moisture sensor, water level sensor and pump pin, and after that we initialize the real serial and the virtual serial for the GSM module. Now let's look at the loop. Water level sensor data will be stored in this water level data, but the problem is analog read reads data from 0 to 1023, but we need data from 0 to 100 for the percentage. That's why we map this water level data from 0 to 100 and save that percentage to water level percentage variable. We did the same thing for soil moisture data as well. After that, we printed all this soil moisture percentage and water level percentage in the LCD and also in the serial monitor. If the soil moisture percentage is less than 50%, that means we have to turn on the water tank. That's why we set this pump into high, otherwise we would set it to low. If the water level percentage is below 50% and SMS send equals to true false and loop iteration greater than 10, that means is SMS send equals to false means we haven't sent any SMS yet, and why loop iteration greater than 10, because we have to give some time to the sensors to get initialized and start working. If all these are true, we have to send the SMS. Now let's see this SMS function. All these are actually the commands. This command is for the sending the SMS. This is where we have to give our phone number, and this is the SMS body. Most importantly, in this function we set the SMS send equals to true. That means we have sent the SMS. Now if the water level percentage is greater than 90%, that means water tank has been filled recently, so we have to disable the SMS send flag. Thank you.
Hello, my name is Chaudhary Mohammad Irfanuddin. My ID is 1910123, and I will cover the lab view as well as the simulation part of the project. First of all, in the GUI part, I have comport selector, then a water tank level indicator, and then below that I have a water pump LED light that will turn on when the water pump is on. I have a soil moisture level meter. Then I have two charts, one for water level and another one for soil moisture. Then I have a table here to log the data of the water level and the soil moisture percentage. In the block diagram, first of all, we are reading the data for the water level and the soil moisture, and here we are doing another thing is because since Proteus is because of all the sensors and modules, Proteus is not really keeping up. As you can see that there is a very high CPU usage, and Proteus is giving us warning that CPU load is too high, and so there are some discontinuity between the speed of Proteus and LabVIEW. Hence, often we were getting null values or zero values as uh, in the serial. That's the reason we have created a feedback loop here. What it does is that it takes the current value and set the current value as the default value. So whenever there is a null value, rather than giving us null, it just gives us a last value as long as new data does not appear. So, and here we are checking whether the tank level of soil moisture is less than 50%. If it is less than, we have coded our Arduino accordingly that whenever the soil moisture is less than 50%, the water pump will turn on, and we are doing the same here. If the soil moisture is less than 50%, we'll just turn on the water pump LED, and on the Arduino part, Arduino will turn on the actual water pump. And then we are clearing the buffer and the entire here we are building the array for populating the table using the water level and soil moisture data, and the entire loop, the entire system is enclosed under this inside this while loop, which will iterate every 1000 milliseconds or 1 second. So let us start. It will take some time to set up, so there are some discontinuity, and eventually it will get stable. So as we can see that it got stable, and we are getting our reading for water level and soil moisture. Let us change the soil moisture first to see the water pump in action. So here also in the LCD display we can check the data as well as in the serial monitor. We will let us decrease the soil moisture, and now let us look at the Proteus, sorry, the LabVIEW, and see the soil moisture is going down, and as it became less than 50, the water pump has turned on. We can also see this in this Proteus part here. We can see the motor rotating. That means the water pump is turned on. Now for the that's all we have with the LabVIEW part. Now we have another feature is that whenever the water level of the water pump will get below 50%, it will send an SMS via this GSM module to the supervisor of this project, who will to remind him that the water to remind him to fill up the water tank. So let us decrease the water level of the tank, and as it goes below 50, so we can see that in the LCD monitor, um, in the virtual terminal of this GSM module, which is here, we can see that all the commands have been printed. In real life GSM module, if we send this command, then it will send an actual SMS message with this particular body, fill up the tank, to the phone of the supervisor, whoever manages this project. So that's all from me. Thanks for watching.